2014, a toxic algal bloom in Lake Erie forced 500,000 people to stop drinking their tap water simply overnight. In developing nations, blooms are just as devastating and lead to the sudden loss of harvest, vital livestock, and large food sources. Currently, tracking algal blooms requires expensive lab testing and results in simply a no swim advisory sign placed near a body of water that is deemed to be contaminated. For the global south, this level of infrastructure is a financial impossibility. Our solution is to leverage existing satellite infrastructure, specifically the Sentinel-3 constellation and NASA's Aquamodis, to identify toxic growth of algae. Our project detects out-of-control blooms as well as the potential upstream agriculture or industrial sources which create the algae bloom.
Okay, so I'm going to show a little bit of our front-end demo and how the satellite captures anomalies on a lake. So if we go to this body of water, we can see that it found two anomalies at this lake. And essentially what happened here was we're pulling data from the NASA satellite in real time, and it's calculating based off the water light refraction and calculating the chlorophyll levels. And you can click on one of the anomalies and it will generate a report, which Raghav will talk more about.
So if we take a look at our final output PDF over here, at the very top, we use a very simple color-coded system. So this alert in specific is a moderate alert, as you can see in the top right. The 1.00 confidence basically acts as our truth check. So it tells the user that the system is 100% sure that this isn't a glitch or any cloud or anything with the image. Next, we have the real-world context. So instead of just giving a raw number, the alert summary explains it in plain English. The water has twice as much algae causing material as normal, and because our weather data shows the sky was calm at this time, the report concludes this isn't just mud stirred up by a storm, it's likely a steady leak or discharge. Next, we have our probable sources, and this shows it doesn't say just a factory in general, it names actual specific facilities nearby, like the PLTGU Java 1 power plant. We then give a 7-hour countdown until that water reaches a drinking intake, turning a satellite image into a specific life-saving deadline.
In developing nations, blooms lead to the sudden loss of harvest, vital livestock, and large food sources. Communities are often led without any warning systems, discovering the toxicity only after a significant loss. These contaminated water sources can wipe out a region's primary protein source overnight, devastating in regions that don't have resources to detect algal blooms early on. By having nations like the United States utilize and refine this satellite infrastructure, we can take the financial burden off of detecting of the algal blooms from detecting countries that cannot support it. We aren't just detecting algae, we are providing a real, consistent, and global solution that identifies runoff sources before they destroy an ecosystem.